Up to this point, we've learned 3 different methods of solving systems of equations, and now we're going to apply those methods to solving word problems. So to solve word problems with systems, you'll need to first start off by determining what x and y, which are the 2 unknowns, stand for in the context of the problem. Once you know what x and y stand for, you'll write 2 different equations, both involving x and y, and then you'll solve that system of equations using one of the methods that we've learned, either by graphing, elimination, or substitution. Let's take a look at example 1. The school that Stefan goes to is selling tickets to a choral performance. On the first day of ticket sales, the school sold 3 senior citizen tickets and 1 child ticket for a total of $38. The school took in $52 on the second day by selling 3 senior citizen tickets and 2 child tickets. Find the price of a senior citizen ticket and the price of a child ticket. So since we can see right away, it's asking you for the price of a senior citizen ticket and the price of a child ticket, then let's go ahead and make those x and y. Now, let's use the information that we are given to write 2 equations. So it says, on the first day of ticket sales, the school sold 3 senior citizen tickets and 1 child ticket for a total of $38. Let's write that as an equation. Since x represents the cost of a senior ticket, if 3 of those were sold, that would be 3 times x, coming from senior citizen tickets. And then, since y represents the cost of a child ticket and 1 of them was sold, 1 times y, or just y, would give the total that comes out from the sale of child tickets. And in total, 3x plus y together was equal to $38. So 3x plus y equals 38. Now it says the school took in $52 on the second day by selling 3 senior citizen tickets and 2 child tickets. Let's do the same thing and write a second equation. So it says that $52 is the total on the second day, and then 3 senior citizen tickets were sold, so 3 times the cost, so 3x, and then 2 child tickets were sold, so 2 times y, the cost of a child ticket. So 3x plus 2y is equal to 52. Alright, so now we have 2 equations, 2 variables, and now I can solve this system. Now it looks like what I can do here is take the first equation and solve for y. So I have y equals 38 minus 3x, and then I can use substitution to substitute 38 minus 3x in for y in the second equation. So I have 3x plus 2 times 38 minus 3x equals 52. And now I can solve for x. So I'm going to distribute that 2 first. So I have 3x plus 76 minus 6x equals 52. Combine the 3x and the minus 6, so that's negative 3x plus 76 equals 52. Subtract 76 from both sides, so we have negative 3x equals negative 24. Divide both sides by negative 3, and we have x equals 8. Now remember, we've only solved for one thing up to this point. So we still need to solve for y. Y is equal to 38 minus 3 times x, and we can substitute that x with 8. So 38 minus 3 times 8. So this is 38 minus 24, which is equal to 14. So to answer this problem, we can say that a senior ticket is going to cost $8, while a child's ticket will cost $14. Let's do another example. Find the value of 2 numbers if their sum is 12 and their difference is 4. So we're solving for 2 numbers, so I'm going to say x is the first number and y is the second number. And now it says that these 2 numbers sum up to 12. So that means x plus y has to equal 12. and their difference is 4. So if I subtract x minus y, that should give me 4. Now you'll notice here that if we were to add these two equations together, the y would get eliminated. So let's go ahead and add these together. This gives us 2x equals 16. Divide both sides by 2, and we have x equals 8. Now we need to solve for y. Plugging in 8 for x into the first equation, we have 8 plus y equals 12. So that means that y has to equal 4. So that means that our two numbers are 8 and 4, and you can quickly check that this works by seeing if the sum of these two numbers is 12, 8 plus 4 is 12, and that the difference is 4. 8 minus 4 is in fact 4. Let's do another example. Castell and Gabriel are selling pies for a school fundraiser. Customers can buy apple pies and lemon meringue pies. Castell sold 6 apple pies and 4 lemon meringue pies for a total of $80. Gabriel sold 6 apple pies and 5 lemon meringue pies for a total of $94. What is the cost each of 1 apple pie and 1 lemon meringue pie? So this problem is asking you to find how much it costs for 1 apple pie and the cost of 1 lemon meringue pie. So let's make those our x and y. Now let's go ahead and write two equations. Let's start with Castell. Castell sold 6 apple pies and 4 lemon meringue pies for a total of $80. So 6 apple pies times the cost of each apple pie, and then 4 lemon meringue pies times the cost, y, of the lemon meringue pies. If we add those together, the total is $80. So 6x plus 4y equals 80. Let's do the same thing to find the second equation. Now we have 6 apple pies and 5 lemon meringue pies for a total of $94. So we have 6 times x and 5 times y equals 94. Alright, so from here, it looks like substitution is going to be fairly difficult here, not impossible, but you'll end up working with fractions. But we do have a 6x and another 6x here, so maybe we can try doing elimination. That means that we have to multiply one of these equations by -1 so that we will have a -6x and a positive 6x canceling each other out. So if I multiply that first equation by -1, I'll end up with -6x minus 4y equals -80. And then I'm going to rewrite that second equation right under it. And now I can add these two equations together, and the -6x and the positive 6x will cancel. That's going to leave me with y equals 14. Okay, so now solving for x, I'm going to plug 14 in for y in the first equation. So we have 6x plus 4 times 14 equals 80. Now, simplifying, we have 6x plus 56 equals 80. I'm going to subtract 56 from both sides. That leaves us with 6x equals 24. Divide both sides by 6, and we have x equals 4. So we've just found that the cost of an apple pie is $4, whereas the cost of a lemon meringue pie is $14.